Hello guys, I welcome to all of you in this video lecture. We will continue our last topic, that is the extreme values of function of several variables. So in the last videos, you have seen that we derive the second derivative test to check the given point at the given point function have local maxima or local minima. So I just recall what we obtained in the last videos. So suppose z is equal to fxy be a function of two variable, then to find critical point we always put fx is equal to fy is equal to 0, and from after solving these two equations we get the point, and we call that points a critical point. Now from second derivative test, if fxx is greater than 0 and fxx into fxy fyy minus fxy square, if this is greater than 0 at point a comma b, this implies that the point a comma b is point of local minimum. Similarly, if fxx is less than equal to 0 and fxx into fxyy minus fxy square, if this is greater than 0 at point a comma b, then this implies that the point a comma b is point of local maximum The third condition is that if fxx into fyy minus fxy square, if this is negative at point a comma b, then point a comma b is a saddle point. And the next important note is here: if fxx into fyy minus fxy square, if this is equal to 0 at point a comma b, then this test is inconclusive. That means this test does not say anything about the local maxima and local minima at point a comma b. So we cannot apply this test in that case. So we have to move for higher order derivative. Okay. Now in view of all these properties, all these points, we will try to find the local maxima and local minima of given function. So we start with example. First example is that if fxy is equal to xy minus x square minus y square minus 2x minus 2y plus 4. Then we have to find its local maxima and local minima. That is, we have to find at which point this function have its the local minima and local maxima. So for local maxima and local minima, we know that we have to put fx is equal to 0 and fy is also equal to 0. This is necessary condition and we call it first derivative test. So fx will be here, this will be equal to y minus 2x minus 2, and this is equal to 0, and from here we obtain minus 2x plus y is equal to 2. Similarly, from here we obtain fy will be equal to x minus 2y minus 2 is equal to 0, and this implies that x minus 2y is equal to 2. Now solving these two equations, we get the value of xy is equal to minus 2 and minus 2. So minus 2 comma 2 is a critical point here. Is critical point. Now we will check either this critical point is local maxima, local minima, or saddle point. So for this we apply the second derivative test. So for this we will get fxx, that is it is minus 2 for all x, fyy is also minus 2 for all x, and fxy is equal to 1 for all xy. So at point fxx at point minus 2, this is also minus 2, and fyy at point minus 2, this is also minus 2, and similarly here this is 1. So since fxx is negative here, fxx is negative, and fxx into fyy minus fxy square at point minus 2 comma 2 minus 2, this is equal to 4 minus 1, that is this is 3, which is greater than 0. So from here we conclude that the point minus 2 comma minus 2 is point of maxima, is point of local maximum, local maximum. Okay, the next problem is that example second, and in this example we have given that fxy is a function of two variables, and this is equal to 4xy minus x to the power 4 minus y to the power 4. Now we have to find its local maxima and local minima. So for this, we first of all we will differentiate it with respect to x. So it gives us 4y minus 4x cube, and now we will put it equal to 0, and from here we get y is equal to x cube. Similarly, we will find fy, and fy will be here 4x minus 4y cube. This is equal to 0, and from here we get x is equal to y cube. Now we can put in place of x y cube, so it becomes y cube to the power cube, and this is y. This implies that y minus y to the power 9 is equal to 0, and this implies y is equal to 1 minus y to the power 8. So we can break this by using factors. So it becomes y to the power 4 minus 1, y to the power 4 plus 1, and is equal to 0. Again, y to the power 4 minus 1, we can rewrite y square minus 1 into y square plus 1. 4 plus 1. So we get real root from a factor y is equal to 0, and from this factor y is equal to 1 and minus 1 only. So when we put y is equal to 1 here, so x is y cube, so after putting y is equal to 0, we get x is 0. Putting y is equal to 1, we get x is equal to 1. And similarly for minus 1, x will be minus 1. So we get three options: 0, 0, 1, 1 and minus 1, comma minus 1. Now we will check the behavior of function as these point. So for this, first of all we will find f(x)(x), and f(x)(x) in this case will be equal to minus 12x square, and fy(xy) is equal to 4, and fyy is minus 12y square. So now we will check at point 0, 0. At point 0, 0. At point 0, 0, f(x)(x) 0, 0 is equal to, now use x is equal to 0 here, so it is 0, 0. Now we will check f(x)(x) into fyy minus fxy square at point 0, 0. So at point 0, 0, this will be equal to minus 4 square, that is 16, minus 16, which is negative. This implies that the point 0, 0 is a saddle point. Saddle point. Now we will check the behavior of function at point 1, 1. So f(x)(x) at that case 1, 1 point will be equal to minus 12, that is negative, and f(x)(x) into fyy minus fxy square at point 1, 1, this will be equal to minus 12 into minus 12 into 4 square. So this will be positive. So this implies that 1, 1 is a point of local maxima. Similarly, we can check for point minus 1 and minus 1. So this is all about how we can apply the second derivative test to check the behavior of function at the given point.